we're on page 9, number 9. What we're trying to look for on this video is the concavity and inflection points of f of x. Now, if you recall, maybe on last Friday, we learned how to find minimum, maximum, increasing, decreasing, and critical points by using the first derivative. Now this one, the process itself is very similar to what we did on Friday by doing all of those. But anyway, you'll see what I'm talking about. So when we look at concavity or inflection points, we said that any of the things that goes with concavity and inflection points, we're looking at the second derivative of the function that we're talking about. So we're going to go ahead and take the derivative of f of x. So my f prime of x would be 3x squared minus 6x. Now, if we were looking at min, max, increasing, decreasing, and critical points, we would just stop here, set it equals 0, and figure out what's happening on the number line. However, we're looking at concavity and inflection points, so we need to look at the second derivative of the function. So let's go ahead and take a look at that. So the second derivative of f of x is 6x minus 6. Just like slopes, just like the first derivatives, if we figure out where the second derivative is equal to 0, that means that's the only time when the second derivatives are going to equal 0, which means everywhere else on the number line has to be either positive second derivative or negative second derivative. So that's what we're going to do. We're going to set this equals 0, and that's the reason why we're setting equals 0. We don't always set it equals 0, but in order for us to do the number line analysis, that's why we're doing setting equals 0 thing. So once we do, we're going to solve for x. So x is equivalent to 1. Now this right here, what we found, let's see what we just found. This is where your f double prime is equal 0. That means when your concavity is equal to 0, or you just don't have a concavity. This is our possible inflection point. We don't know it yet. The signs must change in order for it to be an inflection point. Just like we did last time, we're going to go ahead and graph our number line. So let's go ahead and do that. So our number line looks somewhat like it. And this one is number line of f double prime. Now, I know some of you guys don't like to label things, but I want you to label this for your sake. Later on, when we have to do the first derivative and the second derivative at the same time, if you do not label your number lines, you're not going to know what the number line goes with, and it's going to confuse you. So to prevent that, I ask you to label your number line if possible. I'm asking you, which means I want you to do it, okay? So on my number line, I know that at x equal 1, my second derivative is 0. Now my job, or your job, is to figure out what's happening on the left of x equal 1 and on the right of x equal 1. So if I were to plug in 0, which is left of x equal 1, it's going to give me a negative number. Remember, I'm plugging into f double prime because that's what this number line is for. And then I'm going to plug the right side of x equal 1, which is 2. So if I plug in 2, that's going to give me a positive answer there. Okay? Which means, remember how my double derivative or second derivative of a function gives you the concavity? That means from negative infinity to 1, it's going to be a frowny face. It's going to be a concave down. And from 1 and on, it's going to be a positive concavity. Which means since my concavity changed from negative frowny face to happy face, that makes my x equal 1 as an inflection point. Inflection point. If the signs didn't change, it wouldn't be an inflection point there. Okay? So in order for me to answer this, I have my inflection point at x equal 1. And it's concave down, which means frowny face, from negative infinity to, from negative infinity to 1. It's concave up from 1 to positive infinity. Now remember, concavity is not a certain point. Concavity is like a shape. So you got to tell them from where to where you have this shape, and from to where and where else you would have another shape. Okay? Now, I know it says inflection point, and we only gave them an X point. Usually on multiple choices, it'll say something about find X and Y both. That means if my X is 1, in order for us to find our Y, you see how we have a lot of functions, but we'll still plug it into our f of X and figure out what that would be, because we're looking at Y points, not Y prime or Y double prime. Okay? So that's it for this video. On our next video, we're going to kind of put together the first and second derivative, and we'll see what this function will look like.